Physics Part 348. If the first two fingers and the thumb of the right hand are held at right angles to one another, the first finger in the direction of the magnetic field and the thumb in the direction of motion, then second figure gives the direction of induced EMF or current. An explanation for the direction of the induced EMF can be found by reference to the motor effect and conservation of energy. The figure shows a wire being moved downwards through a magnetic field. Since the wire is in the form of customer or in the form of continuous loop, while the figure shows a wire being moved downwards through a magnetic field, since the wire in the form of continuous loop, the induced EMF gives rise to a current, and the direction of this current can be found Fleming's using Fleming's right-hand rule. This current is at right angles. This current is at right angles to the magnetic flux, and by the motor effect, there will be a force on the wire using Fleming's left-hand rule. The force is upwards when the wire is moving downwards. Reversing the direction of the motion of the wire causes a current in the opposite direction, and hence the electromagnetic force would once again oppose the motion. This conclusion is not surprising when conservation of energy of motion is considered. This conclusion is not surprising when the conservation of energy is considered. An electric current is a form of energy, and this energy must have been converted from one form to another form. Movement to the wire against the electromagnetic field. An electric current is a form of energy, and this energy must have been converted from some other form. Movement of the wire against the electromagnetic force means that the work has been done in overcoming this force, and it is this work which is seen as electrical energy. Anyone who has ridden a bicycle with a dynamo will realize that the work has to be done to light the lamp. The application of the conservation energy is summarized in Lenz's law. The direction of the induced EMF is such as to cause the effects to oppose the change of producing it. Faraday's law of electromagnetism, Faraday's law of electromagnetic induction, and Lenz's law may be summarized using the equation E is equal to d into n divided by dt. See the maths note below, where E is the EMF induced by a rate of change of flux linkage. The minus sign indicates that the induced EMF causes effects to oppose the change reducing it. The shorthand way of expressing the rate of change of a quantity with x time t is the rate of energy of x with t is equal to dx over dt. This represents a mathematical operation known as differentiation. It is achieved by finding a gradient of the graph of x against t. You will come across the notation here in connection with the rate of change of magnetic flux linkage, and in one of these equations for radioactive decay. The conversion of mechanical energy to electrical energy may be shown by spinning a metal disc in a magnetic field as illustrated in the figure. The disc is seen to slow down much more rapidly with the magnet in place than when it has been removed. As the disc spins, it cuts through